which one of these was the one that worked. That was this one. This is one. Today, my friends, we're doing something a little bit different. Since I don't want to sit up today, I want to sit in my bed. We are going to, I'm just going to run one long video, and I'm going to edit it, do some more work on my part. So, this morning, I dropped my logarithms video, which is a unit for my summer course. Like, logarithms was the second unit. The first was data and things like that, and that was easy. It was like Algebra 1 stuff. That's why I didn't post anything pertaining to that except for standard deviation. But I am moving through these units very fast because they're just lessons. You can like watch videos and they'll take quizzes and stuff. But today we have radical functions and things like that. Like the whole concept of radicals and exponents. Like exponential functions, but with fractions, non-logarithmic, like just its own thing. So that's what we're doing today. Yeah, I might just sit here like a normal person. But if I want to go sit over there, you best bet I'm up gonna sit over there. Okay. Okay, so basically, radicals. You've dealt with square roots and things basically the entire time in high school math, since Algebra 1 to geometry, to now Algebra 2. There's been square roots the whole time, right? There's been square roots the whole time. This time, it's a bit more complicated, but not like significantly more complicated. So I'm gonna write to you about some things. So essentially, a fractional exponent. So radicals, okay, I'm gonna expand. Radicals are just like roots of sorts. That's all it is. And then exponents are exponents. And so fractional exponents are essentially just different roots. I'll write it out. So in case you don't know what I mean, I'm just gonna write. So a literal fractional exponent, meaning there's a fraction in the exponent. It seems daunting and complicated, but I promise you it's not. All you do is you take this number, the big number, and you find the root of whatever this number is. So in this case, it's the cubed root, and then you add the numerator. So the denominator becomes the root, and then the numerator becomes the new exponent. So this would be written as 3 to the 8. So sorry, square root of 3. Square root of 3. The cubed root of 8 to the first power. So you just go in a little like triangle. So that's not hard. And so of course, if you had a negative fraction in your exponent, it would just be 1 over the fraction. Hold on. I'm not great at explaining things right now. I don't know why. It'd be either 1 over your radical, or it'd be 1 over x to the y over z power. So in this, they like to act like they're teaching you these new properties and these new functions. But the functions they're teaching are like, sorry, I dropped my pen. The functions they're teaching are like, I'll show you. We'll start with the product property first, which states that any root of any kind, so any root of a number times that same root of a different number equals that root with the product of the two numbers in the center of in the radical, which is this. And it's almost just common sense, But they try to act like it's revolutionary, and it's the same rule for division. If you have this radical divided by this radical, since they have like the same n as their root, you just divide them in the radical. And they act like this is so hard to conceptualize and wrap your head around, but it's really not, in my opinion. It makes it a lot easier, and this will allow you to expand or condense equations when solving them that have and contain radicals. So it's the same thing with the products and like the rules with exponents. So if you have a to the b power times c to the b power, no, I got that wrong. A to the b power times a to the c power, you can just write that as, oh, I already went over this in my last video. Never mind. Go look at my last video. Yeah. And I also have a video on simplifying radicals, so I have like nothing to explain in this video, basically. My last thing I'm going to go over, because I don't really know what else to go over, because this was a very easy unit. Last thing is you can't combine unlike radicals. And this is obvious again. If you have the square root of x plus the square root of y, it's like how you can't add unlike denominators. You just can't add them until they're alike. So you can add the square root of x plus the square root of x, but you cannot add the square root of x plus the square root of y, because they're not the same. So it's like you're adding apples to oranges, and you just can't really do that. You won't get a good answer. Radicals and equations. Again, this is not hard. I hope everyone watching this video knows that the inverse of a radical is squared, or an exponent, right? So that's just basic common knowledge, okay? So when you're solving equations with radicals in them, it's not hard to find your answers, because I'll give an example equation. One thing that did stop me though before I get into this is that when you have to know how to solve all the different levels of equations, like from Algebra 1, I forgot how to solve quadratic equations, and you need to do this. You need to know this to find solutions for radicals. So just remember to factor and how to do the quadratic formula. Yeah. So got our little example equation. This is very basic, run of the mill, easy. So you're almost treating your radical as if it's a variable before it's the variable before the variable. So you have to isolate it. So of course we know how to do that. We'll just add 4 over here like you usually do in equations. So let me do that. So now you have 3x plus 1. No, the square root of 3x plus 1 equals 5. And so then you would square that, because if you square both sides, then it's the same thing. You got this. This is your simple solve for x equation. There you go. This is the simplest it will get when it comes to radical equations, though. I'll show you some where you will end up with a quadratic equation, and then you have to find the 2 solutions, one of which will be extraneous, and so you have to plug them back in and do all that fun stuff that you know how to do. Example would be, so you have your variable before the variable isolated, the radical. So you square both sides, but what is that? There's x on one side, and what is this? Squared? It's a binomial. So you have to multiply binomials, which gives you what? A quadratic equation. Let's go, baby. When I do these, I encourage you to work ahead of me and try to do them before, see if you can get them right. I'm also going to today do a huge load up of my website. I'm going to put all of the videos I used, either my own or other websites, or mainly Khan Academies that I used to help me get very good grades on all these tests. Maybe I'll even post my grades on my results platform. Yeah. Now you have your fun equation of 2x plus 7 equals x squared plus 4x plus 4. So, of course, subtract everything on this side of the equation. So that's equals 0. Of course, simple quadratic equation. You got a quadratic equation. X squared plus 2x minus 3 equals 0. So let's factor, and we'll do it. Let me know what you get. Again, the equation is x squared plus 2x minus 3, and we'll see what we get. You should get x equals 1 and x equals 3. One of which is extraneous. Khan Academy goes into this very well about why one of them is extraneous. It's like some point when you square the radicals, you're losing some kind of information. So don't get me wrong, these two answers are correct. They will solve for this. They are correct in that situation, and they're correct in this equation too. Just for some reason, when you find this for this equation, the original equation, it won't be true because you're losing information when you square radical. Plug your variables into the original equation, which is the square root of 2x plus 7 equals x plus 2. And if it works, if one of them works, then it was good. If the other one doesn't work, that's the extraneous solution. 1 is the correct answer because if you plug 1 in, that equals the square root of 9 plus 3. So yeah, 3 equals 3. There we go. That means 3 is the extraneous solution. Everything I can think of for this unit of radicals and radical equations, because it's not a hard concept. It's kind of things you already know that you're just elevating, which is, it's a common theme in Algebra 2, is you're just taking things you already know and elevating them, except for what I'm learning now, which is imaginary numbers. Oh my god. That's going to be a fun video to try to cover.